Soil investigation. The aim of soil investigation is to collect, analyze data, and determine types and characteristics of soil. Objectives of soil investigation is to identify the nature of soil, to identify the types and depth of the base rock or hard strata, to identify the water levels and pressures. So if you don't do proper soil investigation, you will get something like this, like cracked walls, cracked foundations, building settled unevenly. You will have like tilted buildings, for example, Pisa Tower. So not how to do, but what is the extent of exploration? Like how many points you have to do, what is the depth of the exploration you have to do. It all depends on the site because each site is different. It based on the nature of the land, structure to be built, the size of the project, the cost, the methods, and workers and techniques available, tools available. For example, if you have small work, like a wooden house again, you will only probably need probe Mackintosh soil test to know the bearing capacity of the soil. So if you have larger scale, for example, you have a dam project or generator station, you may need to include some methods. We call it combinations method or hybrid methods, combination of few techniques, boring, sounding, geophysical, right? So the spacing of points of exploration, if you look at the probe Mackintosh that you have seen the video, right? So you have prepared report as well. So basically the points, the distance between one point to the other is about 4 meters. So it depends again on the project. But here typically it says about 10 meters to 30 meters. For big projects, we normally have grids. Macam petak-petak tu dalam macam kertas graf tu, so you will have grids at 300 meters center to center. And for a long or thin project like road work, you maybe need to do about 50 meters to 200 meters distance. However, this is just a general idea. You may have shorter distance, you may have longer distance. It all depends again on the project. Depth of exploration. In principle, the depth of exploration will be carried out until the strata and underground water were determined. At the initial stage of investigation, at least one exploration. So initial stage maknanya masa awal prelim study. For big projects or thin projects like road works, so the exploration is the depth is between 1 meter to 3 meter depth because it's not a high-rise building. So if you have a high-rise building like 16, 17 or like 40 stories, so you will have to do deeper exploration. Factors in selecting the methods, like what are the methods available for soil investigation? There are so many types of soil investigation out there, but basically we categorize it into two. One is what we call the field test, and the other one what we call as laboratory test. And under field test we have prelim stage and also the detailed explorations, but you may hear different techniques out there, but we are just covering this for your knowledge. So for prelim stage we have probe Mackintosh. You've watched the video, and then we have hand auger and trial bits I'll explain later. And detailed exploration meaning you have to do deeper, like you want to know more about the soil. And for laboratory test, you've seen the video about the limit test and also Proctor compaction test, two of this. And also you have carried out the moisture content test together with probe Mackintosh. Exploration factors. It depends, like I mentioned, size of the contract, the type of purpose foundation, whether it's shallow or deep. So if you have shallow foundation, you don't need to do in-depth exploration, because the deeper you go in the ground, it will be more expensive. Types of sample required, whether it's a disturbed sample you need or undisturbed sample. How important is the project? So if the project is very important, you may need to have undisturbed sample, because disturbed means you disturb, you kacau the samples, and we do not want to have that based on the project. Okay. But certain projects, undisturbed sample is fine. You can also have highly disturbed sample. So it depends again. Types of subsoil which may be accounted. So as a general guide, if you have foundation up to 3 meters, you maybe do trial pits. Trial pits means they do trial. We'll talk about that later. And for foundations over 30 meters, so you will need to do more in-depth study like deep boring or deep sounding, and etc. Right. Disturbed soil samples. The purpose of disturbed soil samples is to know the soil types and the texture, the moisture content, the nutrients, the contamination analysis, and so on. Because sometimes if you have a site, you may have different nutrients or minerals in there, and you need to adjust the concrete mixture. If you have more salt in the in the soil, you may need to adjust a bit your admixture of the concrete. And disturbed soil samples, it's easy. It does not require the precision. You can use the backhoe, you can use charcoal, you can just do it manually, hand augers, but you can also use drill rigs for the first layer, yeah. And the collection tools, like I said, you can just do manually charcoal, or you can do the split spoon samplers and different types of samplers. So these are the examples of disturbed soil. So kalau you nampak tu, bila dikeluarkan dah pecah-pecah so it's disturbed basically, macam dah telah digemburkan, lebih kurang macam tu lah. So tanah yang diusik ni selalunya adalah tanah yang dia akan ada masuk ruang udara sedikit kat situ. Undisturbed soil samples, the purpose is to understand the strength of the soil, the permeability, the compressibility. It's more thorough test, and it's difficult to carry it out. Samplers may contain only a small portion, so you may have bits yang pecah. So I asked the engineer, what if the bits in the sampler pecah? So dia kata memang tak boleh pakai, and it happens sometimes at the site. Collection tools sama juga, you only can use drill rigs. You tak boleh pakai trial pits ke, ataupun you nak pakai apa tadi, hand augers, sebab itu adalah for disturbed soil. But for undisturbed soil samples, you have to do it really carefully, and you use drill rigs. So if you can see from the figures, the first one is piston sampler. It has the sampler head, macam skru dekat atas tu, and it also has the curing tip dekat bawah ataupun the shoes at the bottom. And picture tube sampler, the second figure dekat bawah tu, you can see it has 2 layers of tubes. So kalau you tengok lebih kurang, kalau sekali imbas nampak macam lemang. Okay, yang lapisan dalam tu macam daun pisang selalu letak dalam lemang. I have the reason why I'm telling you this. We'll see later. Okay, so let's see. These are examples of samples that have been taken out from a piece of land. So kalau you tengok dekat the first picture yang atas ni, on the left top, you can see different colors of soil from a piece of land. So macam saya cakap, on a piece of land you may encounter different types of soil, and they have different types of tubes. So, kalau you tengok dekat situ, dia boleh buka and you can take out the sample just like that. This is like an example of samplers. You have so many kinds of samplers out there. Okay, so this is Shelby tubing and how to do it on site. I made this video by using 3 YouTube videos I've acknowledged by putting their links on this video. So if you want to see the whole video, you can just click on the link I gave now. Dekat bawah ni ada 3 links. Or kalau tak boleh click, I'm not sure whether you can click or not, I will write this on the description. Okay, so from the picture here, Kalau you nampak, the bottom one yang macam steel tu is the sampler. Okay, and the top one, this is the sampler head, and this is how they're going to do it. We'll see. So they have a point. Okay, so that's the sampler. They have taken out the first bit and now they are doing for the second bit. So they've inserted the sampler in the hole and they put the screw on top of the rod of the sampler, and they're going to connect the push hydraulic machine on the head. So sometimes they say the terms they use is female and male. So it's connected and then they will lock the system so that it doesn't go so they are pushing the sampler right inside and collecting the sample, and they're pulling it up using the machine, of course, and they're going to change it later to pull it, because this is just the pusher, it's not the puller. So now they unlocked it, remove that bit, remove the screw, and they are screwing the lifter. So that's the chain with the screw tip. Okay, so dia screwkan kat situ and then dia akan tarik. So bila dia tarik, so they will get the second bit of the sample. So dia akan buka sampler tu, ni nampak yang dia buka tu. So they are going to send that to the lab. So this is an example of lab sampler dibawa ke lab, dan macam mana dia tolak keluar sample of soil pakai machine. But this is yang dia guna tangan secara manual. This is the third video. So kalau tengok cara dia keluarkan sampler, dia keluarkan sample, soil sample, dia pump guna tangan. Okay, so dia pump dan sample tu akan keluar daripada sampler tube. So there you go, you get a sample. Right. Field test. Kan tadi ada 3 categories. 2 categories for field test. One is prelim stage, the other one is detail, and the third one tadi apa? Laboratory test. So field test, preliminary stage. The first one is probe Mackintosh. You have seen the video yang macam saya tunjuk dekat link ni. You have seen it. And you know how to carry out probe Mackintosh. You have done the report. So I'm not going to describe in detail here about probe Mackintosh. Basically, the maximum depth of a test depends on the site condition and types of building. So the result would provide a rough estimation of the soil layer at a point. So you will have many points on the site. So sometimes you hear people say probe Mackintosh, and sometimes you will hear people say JKR Mackintosh. So what's the difference? In our lab, we have both of the dia punya toe. Okay, we have the shorter one and we have the longer one. So yang JKR probe ni dia shorter, but Mackintosh probe is longer. So that's the only obvious reason between probe Mackintosh and JKR Mackintosh. You will record your reading something like this, and you know how to do it because you have seen the video and you have prepared the report. Hand auger, from the title itself, it says hand auger, means you have to use your hand manually. You also have mechanical auger yang you pakai machine, but now we are discussing about the hand auger. Hand auger is suitable for unconsidered formations like sand, silt, and soft clay because you're using your hand manually. It's not suitable for boulders or batu ataupun gravels. Stiff clay, hard materials, and gravels are difficult unless augering is combined with precaution. Augers can be used up to depth of about 15 to 25 meters depending on the geology. The methods. The hand auger consists of extendable steel rods rotated by a handle. Let's see this illustration. So it's something like that. So you have a handle, macam handle bicycle tu, and you will go around Macam you main dulu game letak kayu baseball kat kepala and you go around, something like that lah. You pusing benda tu. Number of different steel augers, drill bits, dia punya hujung dia ada beberapa jenis mata di hujungnya. Different drill bits can be attached at the bottom end of the drill rods. It depends on what actually you want to take out, or you want to bore, or actually you want to drill. It depends. The augers are rotated into the ground until they are filled and then lifted out of the borehole to be emptied. So these are the drill bits kat bawah tu. You have post hole, or you have helical auger, or you have flat spiral shoe barrel auger. The advantages of hand auger is because it's easy to use and all tools can be made in local workshop. Disadvantages of hand auger: it may be very difficult to remove the temporary casing. It's difficult to use temporary casing because it sticks to the clay. The boreholes does not stay open if a collapsing sand layer is accounted. So kalau ada macam sand layers in between the layers of soil, dia maybe akan terjatuh balik dekat dalam lubang tu. So dia susah kalau ada sand lah, dia akan tertutup. It takes quite some expertise to drill a completely straight borehole. So that's the example of an auger log record. Trial pits. This is interesting. Trial pits is, if you can, you can see the pictures. Meaning you excavate a trench or a pit, and because you want to see the visual examination of the strata. They can be particularly useful when various structure variable condition of contamination is suspected and needs further investigation. It's carried out when the ground is able to stand temporarily unsupported. So kalau sand susahlah, memang tak boleh buatlah teknik ni, because nanti dia akan slide balik jatuh ke dalam, and it's dangerous to the people who excavate inside. Because not only excavator, you can have people who go in and safely excavate it using cangkul ke apa ke, about 1 meters to 1.5 meters. I just want to tell you a story. I think I've mentioned I went to Mercy Malaysia punya mission in Azad Jammu Kashmir back in 2009. So I did the site investigation and my friend did this soil investigation, and he did not bring probe Mackintosh because we were not sure about the types of soil. Daripada Malaysia nak bawa alat probe Mackintosh and pergi sana nanti tak boleh pakai, mungkin we have stones ke apa, it's not suitable. So lagipun masa tu we brought survey equipments dengan parang and all those sorts. Those survey equipments pun dah dengan theodolite semua, they were very heavy. So he suggested to use trial pits, and we had the local people who actually make like pits, bukan trench ya. So we had a pit, and diorang cangkul, and bila cangkul tu kita tengoklah dia punya layers, we record, we how do you say, we make illustrations, and we took samples of the soils to bring back to Malaysia for further for further test. But of course we couldn't test the moisture content at that time because sampai Malaysia dah moisture pun dah lari, so it's not accurate anymore. So that was the prelim investigation we did in the Azad Jammu Kashmir Bagh. So we had only the local workers to safely manually excavate the area for us. We did not have the backhoe because of the access we had. It was really shallow, and we couldn't find any backhoe to dig deeper. Right, so if you want to dig beyond than that, so you need a track-driven excavator. So you need different machineries. More cost-effective than boreholes, but they cannot reach the same depth. Relatively quick. Okay, kalau boreholes, of course, lagi banyak equipment you nak kena pakai. So this is why it's cheaper than the boreholes. However, they can cause significant surface disturbance, and it can be difficult to properly fill excavations when the bed is no longer needed. So basically, when you do the excavation, you dah disturb, betul tak? Area tu you dah disturb. So disturb soil ni, area yang you excavate ni, kalau I patah balik, this area where you have excavated will become unstable because you have disturbed soil. Soil yang you dah ni, dia dah telah digemburkan, so dia tak compacted anymore. So these pits ataupun trenches will no longer be stable. Okay, itu sebab dia kata significant surface disturbance. If the sides of the pit are liable to collapse and access is required, then propping should be carried out, because there are cases where when people excavate manually the trench or the pit, there are the landslide, a very slight landslide, but it caused death. Like a case, this is a real case at my uncle's side. So what happened, the Indonesian labor was like digging the hole. It was a very shallow, dia punya kepala pun above the ground level, the original ground level. So basically dia dekat dalam longkang lah, longkang tu dalam paras pinggang je rasanya. Okay, but nasib tak baik, dia punya tepi tu dia slide. Okay, the soil slide, kena kat kaki dia, bengkok, dia jatuh dan tanah tu tambus dia. So all the workers nearby were trying to help him, apa tu orang kata, what do you say, macam nak ketepikan tanah tu, korek, tried to save him, but they were not able to save him sebab masa tu dia dah choke, suffocated, because tanah tu dia tak boleh bernafas, tanah berat. So just longkang simple pun boleh jadi disaster. So yang sebelah kanan ni ada samples of trial pit. You nampak dia punya layers, they have put the measurements and they have classified the types of layers. Field test, detail stage. Detail stage is more difficult to do and they are more expensive to do. The first one is deep boring. It's fully machinery methods. It requires more time. It requires manpower. It can go more than 30 meters. So we have different types of boring, but here we only touch on wash boring, percussion boring, and rotary drilling. Wash boring. It's for all types of soil except rocks and boulders, and also soft clays. Advancing boreholes for site exploration, that is the purpose of wash boring. It is fast, it is simple, and it is inexpensive. It's simple, just see, because of the tools. Can you see it? Kat sini, they have the tripods and they have the drilling beds. Lepas tu, kalau you nampak, I don't know if I point, you can see dekat bawah tangan pekerja tu, you can see the casing, and you have the winch kat atas ni, and you have the water pipe. It's inexpensive because you only use the drilling bits and water pressure. Okay, so the workers are rotating the casing, and you can see the rods are going up and down. It's raised and drops, and that rod actually at the tip, it has water because that rod is connected to the water pipe. Okay, so that's the guy who's controlling the water pressure. Okay, so you see, that's the rod. You can see the tip of the rod has water. The casing is driven into the soil. You've seen how the casing is driven into the soil, and a hollow drilled rod with a sharp chisels or chopping bit at the lower end. The casing tu ada dia punya chopping bit. Water is forced under pressure through the drill rod, which is alternatively raised and dropped, and also rotated. You've seen in that video as well. So additional casing are attached kalau dia nak deeper, so they will attach additional casing. The rate of penetration and the color of the water will tell the types of the soil. ataupun the soil certification, but not the geotechnical properties. It's just the soil certification. The cuttings is highly disturbed samples because it's mixed with water. It is forced up to the ground surface and then will normally pumped out, or sometimes it just because it is forced. Kalau you nampak tadi kan, water tu dia tekan dan dia naik ke atas, and they can collect the slurry pakai bucket je lah. Slurry is valueless for interpreting the exact geotechnical properties of the soil because this is highly disturbed sample. One you can use for the rock and boulders. It's the same thing, same technique basically, but different machineries. This one you have the chisel bits at the tip, and you will have the real rod or cable, and you use diesel plant and boring tools, something like that, and rotary drillings. You use drilling bits which rotates under pressure in the soil, in the ground. So for rotary drilling, they also use water or bentonite slurry or mud slurry, and again you will have a highly disturbed sample. And you have two types of rotary drilling: open hole or core drillings. And you not only what we've mentioned here, but you have many other types of deep boring. Okay, plate bearing, the second in-depth field test. Plate bearing, it measures two things. The first thing is the plate bearing capacity of the soil, and the second one is the possible settlement under a certain load. So settlements means mendapan, berapa banyak dia boleh mendap. And the test load is gradually increased until the plate starts to settle at a rapid rate. So that's the figure, illustration yang to give you a general idea. Kalau you nampak dekat tengah-tengah ni, dia ada excavate a pit. I've seen also they didn't excavate a pit, but they do it on the surface. So basically they excavate a pit and they will put a plate here, and on top of the plate they will have the jack and dial gauge and everything to read the data. And they will have a beam on top here, and on top of the beam they will have the loads which will gradually increase. Dia letak load tu, dia tengok sampai mana plate tu tenggelam, dan dia akan record, okay, banyak ni dia punya bearing capacity. So ini yang real diorang buat. That's the hydraulic jack, so that's the plate, that's the gauge, that's a reading meters. The counterweight kat atas ni ada beam, so you have weights at the top, and you will have someone here yang duduk kat sini untuk baca dia punya bacaan and do the recording. So that's the plate bearing. Geophysical is typically for mineral explorations like precious stones or oil and gas. So they have different types of or different methods of exploration for geophysical technique. They have core drilling or seismic, magnetic techniques, electrical techniques, and remote sensing. Core drilling is like really deep inside, and seismic they use the wave similar to magnetic, and electrical techniques they use the electrical wave, and they will have rods which they inserted in the ground, and you can read more about this on Projects JNC. And they have also remote sensing methods. These are the explanation of each of the methods. Now let's see one of the examples of geophysical techniques. Let's see this video. I took a bit of the video from the link I attach here. So if you want to see the full video and full explanation, please go to the original video, because this is just for education, right? So that's the soil layers. You can see that's stones. So deep inside, sometimes you have precious stones, and you can have oil and gas as well. There you go. And you have different minerals inside. So this is seismic test. They have the truck with the waves, and they have the geophones. Geophones are something like speaker, but very, very sensitive to waves. So the truck will point a wave, dan based on the layers kat bawah tanah tu, dia akan project balik ni atas pantulan and will be recorded by the, kat dalam truck tu kan ada, dia kata recording truck tadi, so it will be recorded in the truck. So they can use that not only on the ground but also the ocean, deep ocean, to find oil and gas. Yep, so that's about it really. That's a very simple one I just cut from the video. So laboratory test. First one is Atterberg limit test, in which you have actually seen the video. I've told you to see the video, and under Atterberg limit test you have liquid limit test and plastic limit test. I took the pictures from the video I asked you to see. That's the link. So Atterberg limit test is the basic measure of the critical water content of fine-grained soils. It includes shrinkage limit, plastic limit, and liquid limit test. The consistency and behavior of a clayey soil is different, as are the engineering properties at varying degrees of moisture content. So kalau moisture content dia lain, dia punya sifat tu akan jadi lain. As moisture content increases, clays and soil go through 4 distinct states of consistency. Sama ada consistency tu dia solid sebab solid tu kurang air ke, ataupun dia liquid, very liquidity sebab high moisture content. So you can determine that from Atterberg limit test. Then we have Proctor compaction test. This test is performed to determine the relationship between moisture content and dry density of a soil for a specific compactive effort. So you've seen the video as well. I've attached the link down below there. I will also write all the links I have in this slide on my description. So in this video it shows you how to compact the soil and how to actually remove it using the machine vertically. Just now kalau you nampak dia buat yang sampler kan, macam Shelby sampler just now, they push the soil sample horizontally, but this one they push the sample vertically. Basically it's the same technique pun. Okay, this process, kalau dia dah buat, compacted into the mold to a certain amount, and then this process is then repeated for various moisture content, and then they test lah dry densities. Right, that's about it really. Thank you. If you have any questions, please ask in the comments below.